Okay guys, I'm going to go over some of the information from the 16B and C notes so you can do some of your homework this week. You need to pull out your notes to chapter 16B and C. We're going to talk about protons, neutrons, and all the concepts are on this page, so you need to refer back to this page somewhat. And I'm also going to be looking at a periodic table, which is this one right here. So let's go back to our notes for a moment. Protons, remember that protons are in the center of the nucleus, and they're positively charged. They are the second largest mass particle in the atom. There's the protons and the neutrons and the electrons. And the number of protons is the atomic number. And there's that symbol Z that represents the atomic number. We're going to be looking at the periodic chart in a minute. Neutrons are also in the nucleus, and they have no charge. They're neutral, no charge, and they have the largest mass. Now notice here that the mass of the electron is 1,836 times that of an electron, but the mass of the proton is 1,838 that of the electron. So neutrons are the largest, and protons are the second largest, and electrons are the smallest. They're only slightly larger than a proton. And the number of neutrons can be different in the same element, and if they have different numbers of neutrons, they're going to have isotopes. We're going to talk about mass number and atomic number and isotopic notation. So let's write on the periodic table for a moment. Here I started kind of a picture of an atom with 3 protons. So the P the protons are the blue dots, and we're going to put some neutrons in the middle, and the number of neutrons can vary, but so I'll put 4 neutrons in the middle of the nucleus. So the neutrons are the green dots. And since it has 3 protons, in order to be neutral, since protons are positive, remember that? Protons are positive, neutrons are neutral, we're going to need to have some electrons. And electrons, I'm going to use an E with a negative sign. And so that's going to be little red dots. The number of protons and the number of electrons need to be the same. And we talked about before that in the first energy level you can have 2 electrons. So this, we're going to draw the Bohr model of this atom. There'd be 2 electrons, and since there have to be 3 electrons to make this a neutral atom, we have to have a second energy level with that 3rd electron in it. So here's the Bohr model, the Bohr planetary model of an atom with 3 protons and 3 electrons and 4 neutrons. Now, what atom would this be? If it had 3 protons, which one of the atoms on this periodic chart would it be? So what we have here on the periodic chart is these numbers right here. That's the number of protons in the atoms. Okay, so that lithium has 3 protons. 1, 2, 3. This would be lithium. Okay, now go back up here and get my pencil. All right, lithium has 3 protons in it, and so the proton count identifies which atom you have. So if I have an atom that has 26 protons, which atom is it? Well, I go look at the periodic chart. I look at the numbers at the top, which are it's the atomic number. These guys at the top here, like for lithium, 3 is its protons, and it's also called the atomic number. And they use the symbol Z to represent the atomic number. So if I have something that has 26 protons, which atom is it? Well, there it is. 26 protons, so this has to be iron. And iron would have 26 protons total in its Bohr model. And let's see if we could draw that one. I'm going to draw it way down here. I'm just, for the sake of brevity, I'm not going to draw 26 little dots. So we have 26 protons, some number of neutrons. I don't know how many. We're going to have, just put down here like some number of neutrons in the middle of it. Well, how many electrons will there be? Well, if there are 26 protons, there are also going to be 26 electrons. So the first 2 would be in the first energy level. Okay, so now I've got 24 more to go. The second energy level can hold 8. So 2, 4, 6, 8. That's energy level 2. All right, so that's 10 electrons. That means I have 26. I have 16 more to go. And then the third energy level can hold 18, so the rest of them are in this third energy level. So I have 16 more to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So energy level 3 and 10. So yeah. So the second energy level can hold 8, we said. And the third energy level can hold 16. So that'd be 10, 11, 12, 13, 14, 15, 16. I'm just double checking using chemistry knowledge that you don't have to do. So there it is. This would be the Bohr model for iron. Okay, we would have how many energy levels? 3. Energy level 1, energy level 2, and energy level 3. And while we're talking about it, those electrons, remember how they could gain some energy? So let's say this guy right here gets some extra energy and jumps up to this higher energy level, but nature's lazy, so it falls back down. And when it falls back down, it lets go of that extra energy as a photon of light, and we would be able to see that photon of light. Okay, I erased that little atom. Now let's go back to talking some more about protons, neutrons, and electrons. Remember, protons are positive. Neutrons are neutral. Positive, I don't know why I wrote it like that. Electrons are negative. Okay, which ones are in the nucleus? Protons and neutrons are in the nucleus. And since they're in the nucleus, they're called nucleons. Boy, I spelled that horribly. Nucleons, nucleons. Okay, now, electrons are negative and they orbit. They always orbit the nucleus, or they're in orbitals. Remember, the orbitals are the clouds, the probabilities. All right, now let's talk about what isotopes would be then. Let's see if I can get down here. Isotopes. Well, isotopes are atoms where there's a different number of neutrons in the nucleus, but the same exact number of protons. Yes. What? What?
I just linked our Kindle accounts together.
Okay, that's great, but I'm doing this, and I need you to know. I remember that, okay?
I just remembered after I shouted your name.
Okay. All right.
So we can share books and we don't have to both buy them.
Okay. All right.